Hello there, students. In this video, we're going to introduce vector multiplications. To start, let's recall a few things from our tensor video. A rank 0 tensor is what we know as a scalar, an example being mass. A rank 1 tensor is what we call a vector, an example being velocity. And a rank 2 tensor is what we call a matrix, an example being an inertia tensor. Now, we've already seen how we can multiply a vector by a scalar. This is what we call scaling. Instead, let's turn our attention to answering the question, how do we multiply two vectors together? There are actually a number of ways we can multiply a vector with another vector. Kind of weird, right? The first is what we call a dot, or the scalar product. It gets this name because the result of this type of vector multiplication is a scalar. This means we can take two vectors, which are rank 1 tensors, and turn them into a single rank 0 tensor or scalar. The notation for a dot or scalar product looks like this. The second method of vector multiplication is the cross or the vector product. It gets this name, as you might have guessed by now, because the result of this type of vector multiplication is a vector. This means we can take two vectors, which are rank 1 tensors, and turn them into a single different rank 1 tensor, or vector. The notation for a cross or vector product looks like this. You might have noticed a pattern here. First, we can multiply two rank 1 tensors, or vectors, to get a rank 0 tensor, or scalar. This was the dot or scalar product. Or, we can multiply two rank 1 tensors, or vectors, to get a different rank 1 tensor, or vector. This was the cross or vector product. Maybe you're thinking, there must be a way to go from a rank 1 tensor, or vector, to a rank 2 tensor, or matrix, right? And you'd be absolutely correct. Although not really used in introductory physics courses, the first time you might see this kind of vector multiplication is in a course like quantum mechanics. This third type of vector multiplication is the outer, or the tensor product. This means we can take two vectors, or rank 1 tensors, and turn them into a rank 2 tensor, or a matrix. The notation for an outer or tensor product looks like this. Now that we know what kinds of vector multiplications are out there, we'll dive into exploring them in the next few videos. Stay tuned.